here's our last one, number 5. Sorry, on the last one I didn't tell you the answer right away, but on this one it's 5.23 newtons times meters is the torque. So if you got that right, obviously you can move on, but otherwise, listen and I will try to do my best to explain it to you. Okay, we have a pendulum consists of a small mass of 3 kilograms hanging at the end of a 2-meter long string. So we have something where our string is attached and it can freely rock back and forth and back and forth and back and forth, right? Well, they want to know at this point that's 2 meters away from the point of rotation, right? When it makes a 5-degree angle with the vertical, so here is our vertical, so this is 5 degrees, they want to know that when this 3 kilogram mass is hanging here, right, calculate the magnitude of the torque. So again, we want to find the torque. Well, if this is the point that it's rotating through, right, and we know that the only thing that's pulling on it here is our weight, and there would be a tension force in here. Well, remember, torque, the only forces that cause torque are the ones that are perpendicular to the object that's rotating. So if this, right, is the line that our object is rotating through, then our string with our mass, this tension force, we can just totally ignore because it has no component that's perpendicular to the way it's rotating. But our weight, it does have a component that could be considered perpendicular to it, right? It has a part that's also in line with it, but it has this weight that is perpendicular to it. And so we need this component of the weight, and that's the thing that's causing the torque. So what I labeled as an X component is causing the torque. That is a certain distance away. Well, if we're looking at it again, if this is our string and this is our obviously over-exaggerated 5-degree angle, if I have my weight here, right, and I continue with this line, if this angle is 5 degrees from this vertical line here, then my weight is vertical, which means this angle here would also be my 5 degrees, meaning that this X component is opposite of the angle, which means it's sine, right? So our torque equals not just our weight of 30 newtons, right? It's not 3 kilograms, but 30 newtons. We need to multiply that by the sine of 5 degrees in order to get the component that is perpendicular to where it's rotating. And then the distance, it's 2 meters away from the point of rotation, right? That kind of looked like I put it on a ceiling. When you plug that into your calculator, 30 times sine 5 degrees times 2, that gets you our answer of 5.23 newtons times meters. Now, part B says, does the torque increase or decrease as the angle increases? Well, if we were to maybe draw this again, if this is our 5 degrees from the vertical, right, and this is our weight again, we only have this small little component that's perpendicular to it. Well, let's say the string is up here, the string is up here at some much larger angle, right? I don't know, let's say that doesn't look like 40 degrees, but I'm just going to say 40 degrees. Then the weight would be pulling straight down. Well, all of a sudden, that component that's perpendicular to it looks much bigger, and it does end up causing a bigger torque. If we were to, let's say, calculate it out again, and I said I picked 40 degrees, just some random number I picked that was greater than 5, So if I put that 40 degrees in with the same distance of 2, right, because it's still 2 meters away from the plane of rotation, you'll find that that torque there comes out to be 38.57 newtons per meter. So my explanation would be written out in words. The torque will increase at larger angles. The force component perpendicular to the object increases at larger angles. And the torque does increase as proven by my work, because I've showed that at 40 degrees the torque increases to 38.57 newtons times meters. Okay, number 19 and whatever the other one is, forget the other number, they are definitely a little more challenging, so make sure you look back at the examples from the notes, and hopefully you can use number 3 and number 5 to help you out, and you will be successful. But get those done by the end of the hour and turned in.